These notes are going to be nice and short because it's basically what you did in the last section, just with one thing thrown in. So we're going to call these 4.4b, and it's going to be how do I simplify? And again, we're still simplifying what we call radicals or square roots, so I'm just going to go like that. When, the only thing I'm going to do differently is I'm going to throw a number out front. Otherwise, it's going to be identical to the last section, so it shouldn't be too difficult for you. So go ahead and get that written down, get the date, and we'll begin. So what we'll do is we're going to start with a little review. And just one problem from yesterday's. First thing I'd like you to do is see if you can generate the first 10 perfect squares yourself. Pause the video and try to do that. The first 10 perfect squares are 1 times 1, which is never helpful, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. Notice I don't have them memorized, I'm creating them. I'm just taking the next counting number and doing it times itself. 7 times 7, 8 times 8, 9 times 9, and 10 times 10. And I could do that list forever and ever and ever. But these are our best friends when we're simplifying square roots because they're the only numbers in the world we actually know the root of. We don't have to go decimal, we don't have to round. We know without a doubt that the square root of 4 is 2, square root of 9 is 3, 4, 5, 6, anything in between them, we don't know it. Some of them we can simplify though, and remember that we can simplify them if they have one of these numbers hiding in them as a factor. So our goal is to find the biggest perfect square hiding in the number. So let's take a look at the square root of 72. Most people immediately gravitate to 9 times 8 for root 72 because they spot this 9 in there, but 8 still has a 4 in it, so what that tells me is it's not the biggest. The best way to find the biggest one is to take 72 and cut it in half, and you get a 36. And don't look past that. And just when I said that, when you cut it in half, you get a 36, means I could do root 36 times root 2. This right here, I know. Root 2, I don't. So if I were to go to my calculator and make a decimal out of root 72 and make a decimal out of 6 root 2, they're identical. One is just considered simplified. Again, it's really similar to fractions where we say 2/8 is actually 0.25 or a fourth on a calculator. Its simplified version is 1/4, which is also 0.25 on a calculator. These are equal. This one's considered simplified. Same here. Root 72 and 6 root 2 are equal. This one's just considered simplified. So the only thing I'm going to do right now, and notes will be nice and short, maybe 6-7 minutes at the most, is all I'm going to do is discuss what happens when you throw a number out front. And actually, not much happens. All you do is rewrite that down. You just need to do 2 times, and then you find the perfect square hiding out in 18. 3 times 6 is 18, but that's not helpful because they're not in this list of perfect square numbers. So the number that goes into 18, that's a perfect square, is 9. So what I do is I break that into the square root of 9. I always write your perfect square first, times the square root of 2. The square root of 9 is 3. So now what I've got is the 2 from the beginning, the 3 from root 9, and root 2, which nobody knows. So my answer becomes 6 times the square root of 2. So really, the only thing putting a number out front does is it just makes my answer a little bigger. I just need to keep hanging around until I'm done, and then I'll have it. So let's suppose I had a negative 10, and then I did the square root of 300. And you might be thinking, 300, that's too big, I can't simplify it. But it has such a huge perfect square in it. Right here, 100 is just screaming at you inside of there. So the negative 10, I rewrite. Root 300, I spot that it has a big 100 in it. And it'd be root 100, root 3. The square root of 100, I know it's 10. So now I have the negative 10 that was out front, the 10 that I'm pulling out from the root 100, and a root 3 that nobody knows. So I get negative 10 times 10, and then I have square root of 3. And so it's nice and easy when I throw a number out front there. It really doesn't do much to my process. So one last one, and then you can go grab the worksheet for this lesson as a quick little problem set here. So I would suggest try doing this one on your own, and then pause the video and then come back and see how you did. So the number out front stays there. I'm in search of the perfect square that's hiding in 75, pretty clearly a 25 if you can spot your factors. 75 is 25. Sorry, still have my stupid cold. Root 3. The negative 5 still hangs around. The square root of 25 is exactly 5. The square root of 3, nobody knows. Goes on forever, never repeats. And our goal is not to go get decimals. There shouldn't be a single decimal this whole chapter. We're just simplifying. Negative 5 times 5 is negative 25. And then I have square root of 3. And I'd be done. So your next worksheet is going to be green. And it'll be worksheet number... I better make sure about that. I gotta go check. I think it's going to be worksheet number, I think it actually is worksheet number 4, number 5. Sorry if you hear my shoes clickety-clackety. I'm walking back to get a schedule to see what assignment number this is. Yep, it'll be worksheet number 4, and it'll be green. So go ahead and grab that. And that's it for notes for this section. Peace out, Girl Scout. And now I gotta walk back to pause this so you get to still hear my shoes clickety-clacking. Have a good one, guys.